so all are being recorded. As you could observe, I have cancelled the quiz. So actually a lot of drama happened yesterday, because of which I had to cancel the quiz. And that drama was actually related to the undergrad quiz that was conducted by me on Monday. Because I gave the same thing, paper was large and you had just 20 minutes. So many students were not able to upload the quiz in time. So their parents, they went to the chairman and they said that it is so difficult and this like this and that. I told them that actually you have 15 minutes, 5 minutes you should keep for uploading. So then a lot of things happened. Finally, the chairman told me that cancel the quiz. Uh, as you can also see, the order is that all of the examinations will be conducted at the end in terms of comprehensive examination. So I said that, sir, there are many quizzes that we have conducted. So he couldn't answer it, but he said, all right, only for I am specific for this quiz. But he just wanted to imply that avoid the quizzes online. There is no written there that you cannot take a quiz on online, but as I realized on the last two that it is much better that we take the final quizzes and examinations finally in September rather than at this point in time, because of so many problems that the students are facing. Then other we have also teaching problems. Class के बाद so that is why the quiz has been cancelled. So we will just concentrate on the lecture today, and this will be the last lecture. Again, we have covered all the remaining lectures. So this will be the last lecture, and
syllabus क्या होगा final
try to cover as much as possible. Any question do you want to say?
सर मैंने पूछा था सिलेबस क्या होगा फाइनल का
मैं सब कुछ कह रहे हैं तो मुझे आवाज जरा कट गई थी आप
सर मैं कह रहा हूँ सिलेबस क्या होगा फाइनल का ना
हेलो आपको आवाज आ रही है मैं से आवाज
सर मुझे आ रही है आपकी मुझे आ रही सर आपकी आवाज आपको मेरी आ रही
है मेरा रिंग ऑफ हो गया वो मैंने अभी जनरेटर चलाया ऐसे मैंने जनरेटर चलाया हुआ है तो बिजली हमारे यहाँ भी नहीं है तो वो तो शुक्र है जोंग का डिवाइस आ गया है तो दैट इज व्हाई आई एम एबल टू गिव द लेक्चर बट देन I think because the Zong device also needs charging. That is why there was some network problem. In the middle, I was not in the meeting. That is why I've turned off my fan and then I've connected the power supply to the generator so that I can get some power from my Zong device and the laptop.
सर मैं सिलेबस का पूछ रहा था कि फाइनल जो एग्जाम होंगे उनका सिलेबस क्या होगा
all the problems associated with teaching in Pakistan. सारा syllabus होगा because we cannot reduce it. This is comprehension. As we used to have an exam, so you had to have you had a preparation. Now you will have a. So after that you will have two exams. One will be a mid, and other will be final. Now we will see the specifics of what comes. Most of the what is
sir, at
the same time with some gap. So for the whole course now. But you just think as if you are giving the exam of a 70 marks exam, which is midterm plus final plus this quiz remaining. So that will be all included. Heidi, any question? Yes, someone was asking question.
सर फोर्थ जो हमारा जो कोर्स आउटलाइन है उसमें फोर्थ चैप्टर भी इंक्लूड है लेकिन आज के डे में सर वो कंप्लीट हो जाएगा सर उसमें यानी
नहीं, फोर्थ पूरा नहीं हो सकता नहीं यार जाहिर जितना होगा उतना ही इंक्लूडेड होगा सारा तो नहीं हो सकता, आज देख लेते कितना होता है इंशाल्लाह। तो मैं खुद भी हिसाब का हो जाएगा आज, और सीडी में हम कुछ शुरू कर लेंगे, मगर सीडी में काफ़ी ज़्यादा डिटेल्स हैं तो हम शायद सारा ना कवर कर सकें। मगर जितना जाहिर है जो लेक्चर में होगा वही आ सकता है, उसके आगे तो नहीं दे सकता। 1.5 मंथ्स आपने प्रिपेयर करना, पूरे कोर्स की प्रिपेयर करें। आप शीट देखें किस तरह की बनाते हैं, तो कुछ टीचर्स यही कह रहे हैं कि जी वो अलग अलग हो जाएंगे स्लॉट्स में, मगर वो ऐसे ही होगा जैसे जैसे 3 घंटे का स्लॉट है तो 2.5 hours फॉर द फाइनल एंड 1 hour फॉर द मिड, बट it will look as if you are giving the same paper, or the papers will be on campus. University will be opened from September, so hostels will be open and you have to come on campus to give the exam. Adi, every one of you can hear me, or is there some problem? Oh, shukr. Now my network is making some issues. Alright, we go back to the lecture.
सर आपकी आवाज भी कट रही है काफी।
वो कट गई थी, उस वक्त नेटवर्क डाउन हो गया था, आप सही कह रहे हैं। ठीक है, इस वक्त ना हमारे यहाँ थोड़े से मसाइल हो रहे हैं कि बिजली का बड़ा प्रॉब्लम हुआ हुआ है इस वक्त। मैं बड़ी मुश्किल जनरेटर के साथ काम चला रहा हूँ। So whenever it goes down and I am not able to know that, actually I will be always checking the network, no problem. But you can always message me, or you can also call me, sir, this is the problem. So we can do something to tackle it. Alright, so we go back to chapter 4 now. I think you all remember we were studying 2G or GSM or narrowband systems, where we had a set of orthogonal channels. Each channel was in different frequency, or if some users are on the same frequency, then they are in different time slots, as we have seen example of chapter 3. So we were observing their advantages and disadvantages of this system, and at this point in time I think we had studied the performance issue, that actually if you just have one link, then you cannot get any time diversity or antenna diversity or any frequency diversity. So you don't have these multiple antennas there. Similarly, time diversity you cannot get, because if you are just sending your data in one coherence time. But we learned that we can extract time diversity if we use coding, using any of the codes or our own codes. So we repeat our data in consecutive time slots. In slots which are in different coherent time. Okay, we do not send our slot in the we do not send our data in the same slot, but we repeat this data in other coherence time also. So we can also do that in terms of frequency. We send one of our data at one frequency area of 200 kilohertz, and we repeat over so can give us frequency diversity as well as time diversity. Now we were studying the signal characteristics and receiver design. So first of all, you could see that channel was 200 kilohertz. All right, W over N. W is the total bandwidth, and what is capital N? Number of 200 kilohertz channel. All right, so whatever you have to design this number N by yourself, so that W over N is 200. So you will get maximum number of N. You might be getting 200. I think last lecture I told you for 50 megahertz bandwidth, it was coming out to be around 250 channels. So you have 250 channels, and you have to intelligently allocate those 250 channels among your base stations or your city cells, so that neighboring cells do not have the same channels. But the problem will be, you could see that we have a very important problem, or utilization of degrees of freedom. So we saw that one cell was just utilizing 1/7 of the total degrees of freedom or total bandwidth. That is, I cannot use a channel, a 200 kilohertz bandwidth channel in my cell which is already being used in an adjacent cell. You could see the figure here. That was the problem, and we discussed it in detail there. So one is will be allocated some channels. So those will not be allocated to these ones. They will not have that. 1/7th you could see. So you have 7 numbers. So every channel is getting only 7 of the NC channels. So what about the rest of the 6/7 channels? They are not being utilized. This was a major problem for these 2G systems. So let us go further. Now we know that the slots for 577 microseconds. You can go back to chapter 3. You can read there. We have learned about this. And then these slots were actually came out of the division. You have this slot, then you have to divide the slot. You could if you could see the lecture for different users. Now, all right. To minimize the co-channel interference. What is co-channel? Interference coming from the same channel. So you will say that in one cell there is no co-channel interference, because in my cell I have small n number of channels which are at different frequencies in my 550 megahertz. Each channel is of 200 kilohertz. So I have a lot of space. They are not interfering. This is not co-channel interference. Co-channel is the channel interference coming from the same channel. So where is my same channel? Your same channel is present in the other cell which has the same allocation. For example, if you are number 1 cell, there is another number 1 cell. It will have the same channels as yours. So the interference will be coming from that channel because they will be in the same frequency. This will be called co-channel interference. So yes, we would like these antennas have to be chosen as far apart in frequency as possible. Alright. So this is also important. For example, if I get, let us say I have 200 kilohertz, another 200 kilohertz just adjacent to my 200 kilohertz. So some of my signals, because my spectrums are not exactly like a rectangle, they are like sinks, or they have some spread. So again, some interference can also go in the adjacent channels. So first of all, they are further more apart. So this we know. We have 8 slots. Every user is given 1 slot. So transmission suffers no interference from within the cell. Within cell, hardly any interference. Might be some interference from the adjacent, but we do not keep any adjacent cell here. Adjacent channel. So your channel, let us say you have 70 channels in one cell. So those channels will be far apart from one another. All right, so they will not cause interference. So, but where the interference will come, it might come from other cells which are far away from you. And further, see minimal interference. And yes, neighboring cells, they are quite far away, because first we have 1, and around 1 you have these 6 channels. So this becomes 7. Then you will have, you could see here. So you have 1. Then you have these 7 different channels. All right. Then against this 3, you have this here. Again, you have a 2 gap. Then it's your 1. So you can see between this one and this one, you have actually a width of sizes of 2 cells. So you have a lot of space. Okay. So yes, there will be interference, but again, it will be minimized. That is why it is called a narrow band system, because transmission takes over a very narrow bandwidth of 200 kilohertz. So this we said that issues are the same as of point-to-point wireless point-to-point wireless communication means, for example, a transmitter and receiver are at fixed points. So here they are not fixed because the mobile is moving, but still you can see, whereas the channel is fixed, the time is fixed. So most of the issues, they just seem like they are of point-to-point. So because in 2G you don't have these videos, and you don't have these internets, Wi-Fi and all that. You just used to talk and once you are talking, so you have voice, and voice, it's two-way. If I'm talking, so someone else, the other person also talking to me, so it is two-way traffic, approximately symmetric designs. There is no problem. uh, Both the designs are fairly symmetric or symmetrical or same. Yes, and interference is very much minimized. We saw the previously as a discussion in the last paragraph. So SNR will be very large, 30 dB. And then I told you, yes, channel is coherent. I told you what is coherent. Haji, can anyone tell me what is coherent? So I told you many times, coherent means that you know the channel coefficients. ठीक है यार, बड़ी जल्दी बता दिया आपने, thank you. So we know the channel coefficients, ठीक है, and how can you know them? By using channel estimation. Right. So once you know them, and I told you what is the procedure. This channel in estimation, you have the same match filter, but difference is that you know what was the data that was sent. So rather than correlating with channel coefficients, you will take the dot product, or you will, match filter will do the correlation of the input signal with the input signal. So you know what was input, so you will correlate with the input that you already know that was sent. Again, I think my recording is taking some problems. You cannot hear me. All right. I think there was again a glitch here. Yes, a lot of distortion. That is why I stopped talking, because I could see that my voice was not going in. The message was there that you are out of the meeting. That is why I stopped my lecture. Again, coming back, I was just talking about coherent, and I told you this discussed in detail with respect to estimation theory, that you have these symbols, and you cannot get rid of this training symbol, these pilots, they are everywhere. Even 4G, you have a very complex, you could see in 4G, for example, in OFDM, signals now frequency. So all those things, and all of that is happening as we have just discussed in the previous course. Next thing is performance. So performance means what is link reliability. Reliable. Also, 7 microns. And within this corresponding check we also know. So transmission is to contiguous bandwidth, and you have 200 kilohertz, very small bandwidth. Now the delay spread is approximately, roughly speaking, 1/1 microsecond. And I told you coherence bandwidth is 1/2D. So if you multiply this with 1/2 microsecond, and you take 1/2, this becomes to be 500 kilohertz. So coherence bandwidth is 5 kilohertz, and your bandwidth is 200 kilohertz. This means your bandwidth is less than the coherence bandwidth. So you will just get a flat fading channel. You will have no frequency diversity. You have no frequency diversity. So मैंने सारा कर लिया, मैं दोबारा रिपीट करना शुरू हो गया. अच्छा, ये मैंने करवाना नहीं था. मैं स्टार्ट हो गया. Okay. So actually I have covered this. I just but again, no problem. This is being repeated. So you could see here, you have no frequency diversity, no time. But if we could use the techniques that I just discussed at the beginning of the lecture, time diversity with coding. So you use slots, you repeat your data in different time slots, or you send your data in different, you hop your data in different frequencies in different channels, so you could get frequency and time diversity. Now, what are the signal characteristics and receiver design? So we see that the width is 200 kilohertz, and this is in the GSM standard. We have one channel 200 kilohertz. So sample rate is small, and you know what is the sampling rate? So if the bandwidth is 200 kilohertz, you know T is 1 over W. 1 over W with the bandwidth of one channel. So one channel is 200 kilohertz. So it is 1 over 200 kilohertz. And if you find 1 over 200 kilohertz inverse, you can see this will be actually 2 will become 0.5, and this will become 10 to the power 5. It goes in the new 10 to the power minus 5. 0.55 point 10 to the power minus 1 goes here. This becomes 5 microseconds. Yes, sampling period will be 5 microseconds, or sampling rate will be small, roughly corresponding to 200 kilohertz or something per second. Okay. So all the signal operations are of this low rate, around 200 kilohertz. All right. Yes. That's just for sake of your understanding. When I say 200 kilohertz, all right, narrow band, remember this 200 kilohertz, okay, is actually in a passband situation. All right. This means that actually if I take this 200 kilohertz signal at the baseband level, my bandwidth will become 100 kilohertz, because 100 positive and 100 negative. We told you bandwidth is actually positive range of frequencies. All right. So yes, so 100 is the maximum at baseband level. So you know from the Nyquist theorem, its double will be 200 kilohertz. So 200 kilo samples per second you will be sampling. So it is not a very high rate. All right. For optical fiber you have giga rate. That is why it is not that high. Now let us consider the signals that are transmitted by mobile and by the base station in uplink and downlink. So what is the average transmit power? So you could see here that certain devices are devised for peak power, for example this amplifier, and yeah, they are quite inefficient, but they are designed for peak power. So and mostly the power is average. So what we try to get an engineering constraint is that we try to design transmit signal with reduced, not with average, but reduced peak power, so that we are in between average and peak power. So one thing is to capture this purple value, which is power, peak power to average power ratio. So you could see how much peakness is there with respect to the average power. So this purple value is fairly small. In case of uplink, in case of downlink, yes, because you have so many signals, n channel, each channel has 200 kilohertz bandwidth, so you have a lot of channels, so you have large purple. So, but there is no problem in base station because you have AC supply there, and it is fixed, no movement. So, what is the impact of network and system device? Again, you know, we have issues. Issues are of multiple access and interference management. And we could see, oh, very good. You are actually doing very good because almost no interference, very high signal to interference noise ratio. But there are problems. And the problem is this, which I have told you before, in the total bandwidth. So because you have to design your system in a manner, because you have to distribute your frequencies in the whole city, or let us say you have certain area, let us say Lahore city. So you have to be very much like a particular, especially in how to allocate your frequencies among the different channels, because you have channel, they have to be very much orthogonal, they have to be a different set of frequencies. You could see the frequency distribution in the last diagram that we saw. So that is why you have to design with respect to the allocation of frequency in all the neighboring cells. Then also you could see that your other condition, for example, shadowing conditions to one of the n channels. So shadowing is actually, you could see that it is actually a phenomena associated with light, for example, but we see in our home or in office. Let us say I can see in my room light now, there is sunlight which is now quite dim, so I have a cupboard, so there is shadow behind the cupboard, because light directly cannot come because of the cupboard, so light actually infringes from the above and from the right and left, from where it could make some way. That is why you could see shade. One is very dark region of shadow, other is very light region of shadow, and then you have lightness. So there is a continuous transfer of as you move towards the dark shadow, you are continuously moving towards an area where a light is decreasing. So light is electromagnetic waves and mobile signals, and the signal that we use on our Wi-Fi and laptop, all that. They are also electromagnetic signals. They are of light nature. So they also experience them in the same manner. So there will be certain points where the electromagnetic wave will not be reaching. That is called shadowing. Okay? Just an explanation. So because of shadowing, those regions which will be in the shadow, they will not be getting the signal. That is why they are called drops. So this is a a huge problem in industry, how to handle those regions where you are having these shadows or call drops and all that. So yes, once you are in the implementation stage, then one thing is clear, that you are having a lot of problem with respect to degrees of freedom in fashion use. Second thing is in network planning, that first of all you have to see all of those. Then you have to also see respect to, for example, let us say I have a channel, and every channel has different channel coefficients. All of those NC channels, or total of n channels, small n channels, they all have different. Now all of them are facing different. What happens? Let us say that in my channel, that my 200 kilohertz, let us say I have seven 200 kilohertz channels, but this 200 kilohertz channels faces a lot of shadowing. Other 200 kilohertz is not facing shadowing. So actually I have to switch real time. I have to give this and this and this and to that, so that my user could get some signals. Okay? So a careful study is required. So there are a lot of companies, and some I am in touch, where they design these base stations, and they see the topology, the building, and they take the pictures, and they build a model, and then they place the base station and they check all at what type of signal I'm getting a different model. And then they send their receivers, and the boys go out into the field, and they measure the received signal at those stands. They tell all that they are matching with the model or they are not matching with the model. What is the change in the model? And in this way, as the model of that area changes, so you have to update your model, so that you have a careful study of your placement or your topology of the base stations, and the shadowing problems because of interference from base. So one of the base stations will be using, it will cause definitely called interference, and it will cause in the same channel you have another interference channel of the same frequency. So you will not be getting a signal, hence you will be getting shading effects. So 4.2 simple setting with a very simple design of reuse pattern. We saw that it has to be quite involved in a real world system. Just do not get these 7 everywhere. You have to actually check. You might give only 5 channels to some cell because let us say that is not in a populated area, but some cells are very, so you have to give more channels. It is a quite involved study. Another thing, yes, decisions are always in incremental way. You cannot put, if you do not have so many users, you won't be a fool to put so many investment into building your base stations. So yes, if there are users, then you will put your money into the basket. Otherwise, if there's not, so you don't have users, you won't put. If another company occupies more of the market there, so you won't be a fool to give base stations there. But yes, if you want to have promotion, you can, let us say, check that if I can take some of the market from that region, then you can experiment. But still, this is a lot of, engineering and economy, they all are related. So in deciding where are the new ones should be installed, whether we need to install new ones, or we can put load on our initial base stations to provide coverage to all the regions. So once you put a new base station and there are already other base stations of your company, for example, your Zong or Mobilink or other companies, so you have to adjust. So let us say you have put a here, so you have to remove that antenna. No, it cannot be there. So a lot of work is being done in maintaining these systems, so which we are being done already in our country. So I met one of our students, actually he's not a student but actually a bus mate. He used to go with me. So he's working with Nokia, and he's actually providing services to which company? Maybe Zong. Zong or some else. I do not remember. Some company I just see. But he said that actually sorry. So actually, during a talk with him, he said that actually, the Chinese, they were actually, he was with Nokia. So the other company, I don't know, some Chinese company wanted to. So they actually, a large company does not do everything by themselves. So he was saying that Nokia actually got the physical end of that company, physical line, physical link, which we are discussing. Our discuss mostly about physical line. So it is actually क्या कहते हैं उसको leased out. That Nokia. He said that there were different bids. For Chinese company gave a lowest bid, but there were some problems with the Chinese or whatever in their bid, so they were not able to get, and we were able to get. So finally, they realized the Chinese could not handle that system, so we were given the system. Whatever, you will be working with any company. So with the help of this course, you will have a knowledge of the basis, and then you could see why the company needs to allocate these channels in this region or that region. Quarter क्या रहेगा? All right. So we have a high SNR. All right. So you can operate at high SNR. Even those mobiles near the base stations or at the edge, you will still have high SNR. Now, how does a sectorization affect? So what are sector antenna? So within a cell, you can form various sectors, and you can see in an antenna in front of you, base station, you can see that there are sector antennas. They cover a certain region because you have studied antennas. So antennas have a certain bandwidth and frequency, but they also have a you can say क्या कहते हैं उसको आप bandwidth in space. इसको हम क्या कहते हैं, मुझे ध्यान से निकल गया. How much angle do you cover? So based on that, you could sectorize your cells. This antenna covers this much angle, this much angle. This with 360-degree angle is covered in this manner or fashion. So intersector interference can also be seen. For example, let us say if I allocate, all right, same channel in different sectors. All right. So let us say I have 7 channels for my cell, but I say, all right, I put 2 cells, 2 channels in one sector, but I put the same 2 channels in the other sector. So yes, they are in the different sector, they're different antennas giving them, but they are adjacent, they are quite near. So there might be intercell interference in case of dividing your channels uh, with respect to sector, not with respect to cells. One application of reusing channels among the sectors is that the dynamic range is reduced. Yes, it will be reduced. Your signal power will reduce. Your interference will increase because now you have an interference which is much near. But what is the advantage? Advantage is that you will be increasing your degrees of freedom. And then then this is another problem, that your SNR is reduced. So this means neighboring sectors cannot reuse same channels, but at the same time following the design principles of this system. So this means we cannot have sectorization in a manner that we start putting different same channels in the sector of the same cell. We cannot do that. Even we cannot do that. That if let us say if this sector has 3 channels and the sector of the other adjacent channel has the same channels. No. We have seen the design of our system is that we will be giving the channels in one cell, and those they will be repeated after at least a width of 2 cells. Alright. So here sectorization is just related to antenna gain and improved capacity. Okay. It doesn't come from frequency reuse. We don't use frequency because in that case we will have problems. So the next thing is, yes, we are reusing frequency. Let's say after two width of channel we are using. So let us consider an uplink. So one of the neighborings has the same set of channels. All right, let us assume that. So you have a nearby base station that uses the same channels. So what is the interference from this outside the cell interference, or from this in between these intercell? This is not intra-cell, this is intercell interference. Interference from another cell, from a cell outside this cell. So let us say all the cells are in use. So over one slot, a user transmission interface directly with another transmission neighboring cell. Yes. So you have 2 cells and they will interfere if they are using the same channel in both the cells. So what is the signal to noise ratio? So noise ratio will be the power, average power, times the channel mod square. Because the signal, what is signal? Signal is actually x into h. So power will be it's square. Okay. So x square, and h mod square, that will be the channel channel coefficients, and we have studied all of that. Rayleigh, Ricean, and all that comes out to be h mod is Rayleigh, h mod square, exponential, and all that we have seen. And then P, let us say, is average power. So average power is from the symbols, whatever the data you are being sent, that is some average power, but that power is being multiplied with h. So denominator, let us say, it is n naught, the noise, and I is the interference from the neighboring cell. And remember that you can write a lot of good and easy papers if you go to signal processing domain total, let us say in the chapter 3, and you do research, it is difficult there because you have to devise a lot of mathematics. But if you write papers based on, you know, multi-user phenomena, multi-interference, base station cells, uh, they're easy. Mathematically, it is not that difficult, just simple ratios. Okay. And then they have more qualitative effect in terms of research, because you can see most of the people, they will be interested in how can I make my network efficient, rather than going into the, you know, tiny details of mathematics of a point-to-point link. So yes, good thing is that you have knowledge of point-to-point link, but if you're able to translate that knowledge into writing research papers at multi-user level, multi-interference, synchronization, or all these, you know, multi-use system problems which a user or a company is facing day to day, you can have a lot of effect in terms of research, in terms of improving your you know, CV and all that. All right, denominator we know n naught is noise and I is interference. So yes, this is less than, yes, smaller than, yes, let us say 0.2 t, and interference is quite random, because you could see that the let us say the user might not be using the channel, your channel might not be used. In that case, you know, I will go 0. It might be using the channel, but let us say it is quite far away, signals are not coming. All right, it is huge variation. One of the reasons are small scale fading, and the other is the physical location of using the cell. It is reusing the same channel. Yes, physical channel will be changing. In small scale fading, you know, lot of fades, and you know, it is coming to you. It will be fading long term and also small scale. You will be also moving. It will be moving. There will be also small scale fading. So what is the mean of I? Mean of I is quite मतलब के difficult to find, because you have to take the mean over all the interference, all the locations. Huge variation. Interfering could have wide range of locations. Range of I is quite high. Yes, variance will be quite high. And calculating average is also very difficult, and variance will be quite. But you can also do this in MATLAB. You could build a channel model, take off long-term and short-term fading, and you can see the effects. So yes, you can see I is quite variant, huge variations. That is why you could see that SNR is a poor performance. This is another problem with this GSM. First, we had this degree of freedom, and this is the second problem, because under you cannot uh, basically build a good model for your interferer. So it is quite random in location, in frequency, okay, in existence. Yes, and even you cannot improve your SINR if you apply all the diversity techniques of chapter 3. All apply antenna diversity, apply time diversity, apply your frequency diversity. This will never improve, because you will not be designing your diversity technique with respect to the interferer. Interferer is not in your control. It is coming and going from, you know, infinite locations, and you do not know that, let us say 8 users are using it, and let us say 8 users are moving here and there. Wow, you are in a lot of trouble. No amount of diversity can provide you any help here, because your diversity is with respect to your signal. It won't help you in dealing the randomness of the interferer. There will be quite random, huge variation. That is why they are unsuitable. Narrowband systems are unsuitable for universal frequency reuse. They were not designed for universal frequency. They were just designed for orthogonal set of frequencies. Okay? Yes, this is this much, all right. Good SIR. So there are huge problems there. And then you have randomness in ISINR. We would like that interference could be averaged out so that we could get, we don't have these high variations in SINR. So in the next systems, this was taken care of. So, we have shortage of time, so we won't be able to cover a lot of this, but we will try to cover as much as possible. So 3G systems come. So next comes this CDMA system, 3G systems. So there 2G you had these disjoint time frequency stops, okay, and all that. But in CDMA what happened? Quite different, huge difference with respect to 2G. And as we saw that each user data, which is a very small bandwidth, is actually spread over a very large bandwidth because of pseudo noise sequence. You multiply, chip rate becomes very, very high. You go to megahertz instead of kilohertz. So all the users, they become pseudo noise. You will see in a while, all the other user signals, they will become pseudo white noise. Aji, what is the property of white noise? जरा पूछे ना बच्चों को. आज तो कवायवा ले लेते हैं अपन. कितने बंदे हैं आज? 5. All right, let us have a quiz now. You cannot have a quiz because of I have told you the problem that we were facing. But again, I have told you already, we can have these. These bonus mass questions. So today is Wednesday. So I start with Chaudhary Umair Saab. Do you remember what is white? What is white noise?
सर ये discrete signal.
अच्छा, discrete signal. अच्छा जी, शकुर अहमद साहब, what is white noise?
सर उसके जो पीडीएफ होती है प्रोबेबिलिटी ऑल फ्रीक्वेंसी पे वो सेम होता है, जो उसकी डेंसिटी होती है सर, ऑल फ्रीक्वेंसी कंपोनेंट पे उसकी सेम होती है, वाइट होती है, फ्लैट होती है सर.
हाँ, ऑल फ्रीक्वेंसी पे उसकी सेम होती है, ठीक है. और उसका ऑटो कोरिलेशन कैसा होता है?
सर ऑटो कोरिलेशन इसका आप उसके साथ करेंगे तो टोटल उसकी एवरेज 1 ही आ जाएगा सर, उसको अपने के साथ करेंगे तो सर.
यानी वो भी कांस्टेंट ही आएगा, जैसे वो था, जैसे फ्रीक्वेंसी वैसे ही ऑटो कोरिलेशन, ठीक है. अच्छा जी, अवैस मक्का साहब, आप क्या कहते हैं, इसकी ऑटो कोरिलेशन कैसी होगी वाइट नॉइज की?
सर डेल्टा फंक्शन होती है.
हाँ, डेल्टा गुड, वेरी गुड. वो देखिए ना, उधर फ्लैट है, जैसे सकूर साहब ने सही कहा, क्योंकि फ्लैट है. तो उधर फ्लैट है तो फ्लैट का पावर स्पेक्ट्रल डेंसिटी फ्लैट हो गई ना इसकी, तो इसका इन्वर्स फोरियर इसका ऑटो कोरिलेशन होता है, ठीक है. ये हमने देखा था पहले भी बहुत दफ़ा. तो ऑटो कोरिलेशन फंक्शन जाहिर है कि वो डेल्टा होगा. वाइट नॉइज का पहले भी पढ़ चुके चैप्टर 2 में, तो लिहाजा वो डेल्टा फंक्शन होगा. वेरी गुड, ठीक है. 3 लोग रह गए, उनसे मैं फिर बाद में सवाल पूछ लेते हैं, एक और सवाल आ जाएगा इंशाल्लाह. अच्छा, हम क्या पढ़े थे? All right, so here every other user will be a pseudo noise sequence or pseudo white noise. Again, everyone will be sharing the same frequency. Very good thing. Not only all users share all the time frequency degrees of freedom, so in different cells. Not only users of same cell, but users of different cell. They are all spread in the same time frequency resource. The best thing of frequency reuse is happening in CDMA. So you can see the interference is white noise. And again, You will see the interference kept to a minimum. How this is done? First of all, the receive signal of every user is random pseudo noise. Yeah. Oh, Acha, I'm sorry. We have to take a break of let us say 4 minutes. Just have to turn off my generator and then I have to switch on to Wabda supply. So I will cover this 5 minutes in the lecture. All right. It just take most hardly 5 minutes. Even less than 5 minutes. Please give me a break. Hello? Everyone can hear me?
Yes, sir.
All right, good. So coming back to the lecture here, you could see that everything is random. Every signal is random. All right, so there is not as if there is a huge interference. Everything is pseudo noise. So all the signals have been reduced to noises. In this way, you have reduced those interferer signals by making them, pseudo Gaussian or white Gaussian. Second thing is power control. This we will also learn if we get time. I do not know if we are getting time or not. So there is a very good power control in CDMA. Okay. So a user is given only that amount of power which is required for demodulation. Okay. And it is in full control. You won't give you won't be sending power greater than to the required power, because in that case it will cause interference to other users. So those users who are near to base station, they will be getting less power. Those who are far away, they will be getting greater power. All right. So interference from users closer to the base station will not overwhelm users further away. The so-called near-far is a very important problem in wireless communication, near-far problem. So by having this power control, you are able to handle that. So you were giving less powers to closer than. Otherwise, if I do not have power control, let us say in the last system, so the near system, it is already near and it is getting a lot of power. All right. Similarly, when it will be sending, it will have large power being received at the base station because it is very near. So you could see its interference will be large to other users. So this was also handled. Then averaging. So you could see in GSM we couldn't average because you could see that every user was actually given an orthogonal channel. Or let us say 8 users were given one channel which were actually orthogonal in frequency and time. But here no problem, everyone is given the same channel, full frequency reuse. And sum is Gaussian. So you take average of so many users, every random process becomes Gaussian. And this is very important because this randomness is actually averaged out. So it is quite random. Every user is different, is going here and there, but they are at the same channel level. So all of them are causing the same type of interference. So many interference, it becomes Gaussian. And this we will see it is a key to increasing the reliability of 2G systems. And then a key for frequency reuse. That is why it was built up from the 2G system. So you could see now hardly 2G is there. Mostly we have switched to 3G. S2 is there, but 3G and 4G are running. Currently, you could see here in Pakistan. Mostly now it is 3G. So this 3G is this which we are studying right now. Okay. So each user is a point-to-point wideband with additive Gaussian noise. Yes. Each user will be now have a wideband channel with additive Gaussian noise. And yes, and each user we can say it is point-to-point. Because why point-to-point? Because you have a pseudo noise sequence. No other user has the same pseudo noise sequence. So you are actually orthogonal. Because two noise sequences pseudo noise, they are orthogonal. We said it in chapter 3. In addition, you can apply diversity techniques. All right, time diversity. You can repeat your data. You can also use frequency diversity, because we saw that you have these L symbols, and you can use L symbols, L क्या कहते हैं उसको, ISI of L channels, L multipaths. We use them to get that gain. So many gains you can get. Then you have rake combining, antenna diversity, rake combining. You saw that you have these fingers of the rake receiver. Each finger is tuned to a certain channel. So it is actually frequency diversity. It's a rake combining, because you are getting the signal not only from one H but several H. Each H is corresponding to the L different multipaths. This is rake combining. We saw in chapter 3. So reliability can be increased. So you have a lot of tools, lot of weapons at your hand to increase your signal reliability. So yes, CDMA is quite different. And the main difference is that it lets the user share all degrees of freedom at the same time. So no one interferes with the other. And you can see that the system is interference limited. In 2G you don't have an interference problem, but you had a degrees of freedom problem. And at the same time, you take the advantage of 2G, because you are dividing your links of mobile with based into a point-to-point link. So each link just sees an interference with other users, and the thermal noise, the noise, additive wide Gaussian noise. So we'll be studying here the CDMA and all that. So it has huge benefits. First, we saw frequency reuse. All the cells get the full bandwidth, full degree of freedom. By narrowband system, you had this problem. All right. You have to get only I have only these cells. I'm sorry, I cannot give you more cells. But here there's no problem. Put them on the channel. You have a universal frequency reuse. Yes, you cannot put, Dr. Asim Noor, he was one of the pioneers of building 3G systems in America. And you can also learn from him. So when we were learning, we were studying this course when he came from Rika and LUMS. He used to tell us that above 64 users, then we started having this interference problems. But still, you have a huge, you don't have a hard constraint like in GSM. In GSM, you have fixed. Let us say I have 7 channels for my cell. Each 7 is, let us say 7. Each channel is distributed to 8 users. So what is 7 times 8? 7, 7, 49. 7 times 8, 56. You can just put 56. You cannot put any more users, provided if you have 7 channels. Let us say you don't have those many users. So your channels are still going waste. Here there is no problem. Put them. Everyone is noise. Actually, it will depend on how many pseudo noise sequences can exist. Okay. So all of them are orthogonal. As much as you can allow, you can put them in the same channel. Okay, so it can take, and if there is less people are not using, no problem. All right. So you will have less frequency. You have less, users. So other cells which have more users, they will be utilizing the same channel bandwidth. So this is Azan here, but the lectures will be ending. Let us say only 3 minutes of this break which came. So we will inshallah ending our lecture at 7:80. Okay, no problem. So I will try to take the attendance at approximately 7:30. So we can do as much as possible. All right. This is the last lecture, so you can learn and I can learn by teaching you. So you will see here that yes, SINR will reduce for CDMA. As SINR for GSM was high, but here it will reduce because we have the same channel for everyone. But you will see how we can deal with that also. So again, you have an aggregate interference level. If a user stops transmitter, it's the same thing. The total interference level will automatically go down. All right. Yes. And users are independent. This is like a statistical multiplexing. And you can accommodate much more users as compared to a same narrowband system. Because for narrowband, you have to explicit assignment of time and frequency is required. But here, no explicit. For example, this is very, very important advantage. Very, very important. Especially from, market point of view, making money, economy point of view. You cannot put new users into your 2G network once you run out of your time frequency slots. Called hard capacity limit. But no problem in CDMA. Put users, no problem. Maybe here you have large number of, let us say in the remaining, in the adjacent cell, less number of users are there. They will cover because the aggregate interference is working out. It's very, very important and advantage of CDMA. Very important. That is why 2G will take a back seat. And it has taken a back seat. Now you could see most of the mobiles, we try to say, all right, let us say, all right, they are backward compatible. But in this market, trying to buy, 4G mobiles were quite expensive. 3G mobiles, smartphones were they have become cheaper. Yeah. Most graceful, degradation in the performance of the system, and was a soft capacity on the system. Very, very important. Yes. So you also have the soft handoff capability. You can tune your base stations. For example, if I have a cell which is at the edge of the cell, so it will be getting signals from both the base stations. And in this way, you can have a soft handoff. You can get the signals from both the cells. So both the base stations will be getting the signal. They will send both the signals of that single user to the MTS, the switching center, and it can decide which signals are better, and hence it will take those signals. Again, it increases the capacity of CDMA systems. But अच्छा हाँ जी, अच्छा जो लोग रह गए उनसे जरा पूछे ना, सवाल तो पूछे. अच्छा जी, मैं 3 बंदों से पूछ लिया था. हाँ जी, गुलाम मुस्तफा साहब मौजूद हैं? गुलाम मुस्तफा.
जी सर.
हाँ जी, could you have this capability in GSM? This soft handoff.
GSM में क्या?
Could GSM afford soft handoff? Could it can do this handoff, soft handoff, that both the base stations of the adjacent cells, they are getting the signal of the data of the user?
I think yes, sir.
All right. Haji Sumair Khan, what do you say? Is he right?
Sir, I don't think so. Sir, two stations same signal handle.
You can see what is a soft handoff. The words are there. he's saying that soft and both base stations are getting a signal for the single user. So can this happen in 2G or not?
2G में नहीं है सर, मेरे ख्याल से 3G में है.
तो लिखा हुआ है ना 3G में तो है. But can this happen in 2G? You are saying it can not happen. But then I am asking why it cannot happen. Why cannot happen in 2G? Okay, Salman Khan, same question. Salman Yusuf, sorry. Haji, why it cannot happen in 2G? So Sumair Khan said that you cannot have soft.
हाँ जी सर, नहीं हो सकता क्योंकि दोनों जो सेल्स होंगे ना डिफरेंट, उनमें डिफरेंट फ्रीक्वेंसी होगी, सेम फ्रीक्वेंसी स्पेक्ट्रम शेयर नहीं होता.
Very good, thank you, very good, very good. This is the right answer. So I am happy that today many students have given correct answers. This shows that you have learned. I'm sorry the quiz could not be conducted because of the reasons I have spelled out in the beginning of the lecture. All right, let us go further. So advantage of CDM is again this here. All right, let us see. So in addition network, there is a further link level advantage over narrowband systems. Yes, and this very important thing is frequency diversity. You know, we studied frequency diversity. CDMA has this, huge spreading of data in, in frequency and in time. You have huge small chips, and then you can get a huge type of gain. Let us say 128 gain you can get. So that gain you cannot get in these narrow band. There, for frequency diversity, you have to hop from one channel to another channel. It is not that easy to hop from one to another. Most of the time, you are just in the 200 kilohertz same channel. But here, there is no problem, no requirement of hopping. Okay, you have the same channel and you have a huge multipath phenomena. Right? We saw 100 block length, and then you have 12 channels, 12 multipaths for 12. Could utilize them. All right, and very important. And this is particularly important in slow fading environment. Why slow fading? What is slow fading environment? अभी बंदा रह तो नहीं क्या? आज ये 6 ही बंदे हैं ना आज. Any person other who is present? Only 6 attendees. All right. Only 6 attendees. So no problem. So I don't ask more questions. I think you will feel difficulty here. Yes, why? What is slow fading? That signal is changing very slowly. This means you have very large coherence time. So if you have large coherence time, you cannot apply a time diversity. You cannot send your same data in a different slot because you are after a very long interval of time, you are getting the different channel. The user cannot wait for such a long time. So you have to switch to frequency diversity. So here you have a lot of frequency diversity in CDMA because of that, the spreading of the signal. You could also have frequency diversity in GSM, but there is not, because you are sampling at the same data rate. Okay, but here, data rate is very, very high. Chips are small and they become compatible with the delay spread, and thus you have a very large amount of frequency diversity or number of multipath channels. It's another advantage over 2G systems. That is why 2G mobiles are almost finished now. But yes, you will see if we cannot cover 4G now, but we can see 3G mobiles. That is why the reason that they are so cheaper. They can strike these things, but they are still they fail when they try to compete in some things with respect to 4G. But then 4G is expensive. That's the problem. Cons of CDMA system. First thing, it is not that easy to control this power control. And then you have these channel attenuations of nearby, and huge interferences are there. Yes, we know. Everyone is using the same channel. So these are the drawbacks actually that are overcome by OFDM. But we cannot cover that because of lack of time. And you have to send a lot of information about power control, and this requires a lot of overhead. But in narrowband system, you do not require this power control because everyone is orthogonal. Yes, you have sufficient out of cell interface, lot of interface. Yes, this is there. Yes, so yes, it is actually it is everywhere. Quite in the uplink, because you have all the cells which are all using the same channel, so there will be interferences. And even in the downlink, so you have two base stations, and the base stations are again sending the same link. So you will also have interference. Interference is there. We cannot deny that. So a capacity comparison between CDMA and narrowband systems. So yes, it will depend on the coding schemes, power control strategies, channel propagation models, traffic and arrival patterns, and it's beyond the scope. This is more of an industrial. So those who are sitting in industries, they will be actually handling all that. I applied 2G and 3G, and they can mainly, it also depends on the user. If user wants more data, he has to switch to 3G. He cannot stay at 2G systems, but still if the user do not want, then you can also switch to 2G systems. But still, overall 3G is quite better. You can see the advantages there. So I have already told you that if students are interested, at least 10 students must be interested. So we can offer another high level course based on this subject. If the students are there, then I will offer. Otherwise, I will not offer. So I've already told you. So you could learn more about the industrial aspects, and this will help you in getting slots in different communication industries. Especially once you are well versed with wireless communication systems, this means almost all systems are covered. So we are in the last minute here. So they have their pros and cons, but overall this is quite better as compared to 2G because of frequency, universal frequency reuse. All right, so time is up. I won't go further. So we have our course will end because, as announced by the department, this is the last week both for undergrad and graduate studies. So whatever we have covered, this will be the course. So our course will be before 4.3.1 CDMA uplink. So exams for masters, as we have been told, will be conducted from middle of September, from 15th September on campus. So all the marks that are remaining from midterm, final, and one quiz, they will be conducted during that time. So prepare for the full-fledged course. This is just like annual system, where you have just one exam. So you will have one exam of 80% marks, and you have to prepare for it all. You will have a 45 days break of 1.5 months break where you can prepare for this course. So I will be available on MS Teams, so you can also ask questions. So as I get time, I will answer them. All right. So I will take your attendance. If anyone has any questions, you can ask questions during the attendance time.
ये जो सर न्यू कोर्स ऑफर कर रहे हैं, ये नेक्स्ट सेमेस्टर में होगा या उससे नेक्स्ट सेमेस्टर में?
जाहिर है नेक्स्ट में होगा. नेक्स्ट में अगर आप तैयार हैं, जाहिर है वो मैं 10 से कम पे तो पढ़ाऊंगा नहीं. वो आपको पता है क्या हालात है यहाँ पे. पहले तो हो जाता, पॉसिबल ही नहीं है. तो 10 अगर होंगे तो मैं ज़रूर पढ़ाना चाहता हूँ. मैं भी चाहता हूँ कि मेरी भी नॉलेज में इजाफा हो और थोड़ा सा आपको भी फ़ायदा है. अब दुनिया 5G पे जा रही, तो अगर हम इनको नहीं समझेंगे तो हम आगे कहाँ से करेंगे. और मैं देखिए बाकी तमाम कम्युनिकेशन में यही सारी टेक्निक्स आ रही होती हैं. तो लिहाजा ऑफर अगर स्टूडेंट्स इकट्ठे हो गए तो ज़रूर होगा, वरना फिर मैं एरे सिग्नल प्रोसेसिंग ऑफर करूँगा. स्टूडेंट्स आगे तो आगे, वरना फिर ऑफर नहीं होगा.
सर ये जो नेक्स्ट कोर्स आप ऑफर करेंगे, इसका प्रीक्विजिट ये वाला होगा, क्योंकि न्यू बच्चे तो नहीं आ सकते.
जाहिर है, बिल्कुल होगा, बिल्कुल 100% होगा. इसके बगैर कैसे हो सकता है? आप खुद सोचो ना. वो तो हम कर ही नहीं सकते ना. वो तो ये तो मजाक होता है अगर ये कोर्स ही ना पढ़े, मैं उनको आगे पढ़ाना शुरू कर दूं, उनको कम्युनिकेशन के लिंक ही ना बनाने आए और हम सिस्टम कैपेसिटी और माइनों में चले जाएं जो आज वक्त करंट चल रही रिसर्च, तो वो कहाँ से समझेंगे? ये कोर्स तो मस्त है, जो नहीं करेगा वो नहीं कर सकता.
यानी कि इसी कोर्स में से 10 बच्चों को आना पड़ेगा आगे.
हाँ, नहीं तो पिछले भी तो पढ़े हुए हैं, उनको क्या मसला है? तो पिछले से हैं, PhD के बहुत से स्टूडेंट्स हैं जो इस पर मेरे बहुत से PhD के स्टूडेंट्स इंटरेस्टेड होंगे जिन्होंने नहीं पढ़ा हुआ और उनको ये नॉलेज नहीं है और उन्हें प्रॉब्लम्स आ रही हैं इस वक्त. वो जो बनाने बैठ जाते हैं साइनॉप्सिस में, वो कहते हैं जी वो रिसर्च का टीचर्स रिजेक्ट कर देते हैं उनका साइनॉप्सिस. उनको ना मैथ आती है ना उनसे वो इंग्लिश लिखी जा रही होती है ना, वो हम ठीक ठीक करके मर जाते हैं। अब ज़्यादा स्टूडेंट्स वो लेके ही बैठ गए। खैर एक मेरे पास नफ्स है, मुझे टाइम नहीं मिल रहा, मगर ये सारे मसाइल हैं मेरे पास। कुछ मेरे स्टूडेंट्स भी आएंगे, हाँ ये तो आपकी बात सही है, वो तो फिर हमें देखना पड़ेगा। कुछ मेरे स्टूडेंट्स पीएचडी के आ जाएं, कुछ हो सकता है कुछ और पुराने मास्टर्स के आ सकते हैं। एक अटेंडेंस में डाल दूंगा, क्योंकि हमने एक्सेल लेक्चर इंशाल्लाह कवर किया, हमने बहुत ज़्यादा पढ़ा था, 2.5 घंटा, तो आज की अटेंडेंस 29 की लगी। जी हाँ 19:05 तो प्रेजेंट है, मैंने आवाज़ सुन ली। 18:35, 18:36
Present. Present, sir. 35.
18:37
present.
18 और 35
Present
35
35.
absent। अच्छा 36 कौन है?
Yes, sir. Hello.
अच्छा प्रेजेंट, गुड, ठीक है ठीक है। ये कौन है? 30 अमीर हमजा, चलो ठीक है।
Yes, sir.
37
Yes, sir.
ठीक है ठीक है ठीक है। 37 39 42 1842
Present, sir.
1862 1842 62
42.
अच्छा 42 62 प्रेजेंट। 1863 1941 1942
प्रेजेंट।
हो गया। 1943
यस सर।
ठीक हो गया, 7 हैं टोटल आज, ठीक है। और 1946
यस सर।
ठीक है, 3 और 4 7 ठीक हो गए, चलें ठीक है। So I will thank you for your continued interest in this course. So I hope this course will help you both in your professional life as well as in your as well as improving your skill set of learning about the different streams of communication. So I will stop the recording here, and inshallah